Okay, so today I want to take a look at calculating a resultant force here from multiple force vectors. We've got some practice problems we're going to do. I'm going to go through the first one with you, and then you're going to have, I believe it's 3 others to go through yourself. Just to review, remember, we can only deal with forces in the x and y direction, and an angled force such as this, angled force, which causes that object to move, can be replicated or broken down into a single y and a single x force. And so by combining an x and a y force, we can have the same resultant motion. So all of your force vectors that are angular forces must be broken down into x and y components. So the problem we're going to look at is number 1. We're going to go through 4 steps in order to do this. The 4 steps are as follows. Number 1, draw a free body diagram for the force vectors. Step 2, solve for the x and y components for each of your angled force vectors. Step 3, sum all x forces and then sum all forces acting in the y direction. And then step 4 is use those summed forces to calculate the resultant force. Okay, so step 1, the very first thing we want to do here is draw a free body diagram. And we're just going to take and draw here. Here's your center of your road. Okay, we have force 1, just 750 pounds, and it was acting 15 degrees counterclockwise from the center of the road, or the y-axis. So we have a force acting out this way, right here. We're going to call this force 1, which equals 750 pounds, and it is acting 15 degrees from the positive y-axis. Now then we have force 2, the tow truck 2, which was acting 25 degrees clockwise. So 25 degrees clockwise is force 2. It equaled 1,500 pounds, and it was acting 25 degrees from the positive y-axis. Okay, so now that we have those, now we can break these forces out and we can solve for their component forces. So if we look at force 1 by itself, force 1 acts off in this way. Force 1 then has a force 1 y component, and it has a force 1 x component, and it's acting 15 degrees out. Okay. Now this is where we start to use our trig functions. And if we want to solve for force 1x, force 1x is the opposite to the angle. Remember, our trig functions are some other hippie caught another hippie tripping on acid. Okay, so we have the opposite, and we know force 1 equals 750 pounds. So we need to use the opposite and the hypotenuse, which is the sine function. So we know that the sine of 15 degrees equals the opposite, which is force 1 sub x divided by force 1. And we know that force 1 equals 750 pounds, so we can sub that in. All right. And then we need to isolate force 1 sub x because we need to solve for the x component. Force 1 sub x is the x component force of force 1. It's the amount of force that's acting in the x direction. So in order to isolate force 1 sub x, we need to multiply the whole thing by force 1. And remember, force 1 is 750 pounds, so I'm just going to go ahead and sub it in right now at 750 pounds times the sine of 15 equals force 1 sub x, because force 1 will cancel on this side, leaving us just force 1 sub x, and it'll be multiplied by this side. And remember, force 1 equals 750 pounds, so all I did was sub this out. This is the same as writing F1 times the sine of 15. Okay, so we want to solve for force. We want to figure out what force 1 sub x equals, and force 1 sub x is going to equal, we take a look at our handy dandy calculator here, we're going to take 750 times the sine of 15 degrees, all right, make sure you are in degrees mode in your calculator, hit equal, and it is 194.1 pounds, 194.1 pounds. Okay, and we're just going to take that and I'm going to write that up here. Force 1 sub x equals 194.1 pounds. Okay, hopefully that makes sense. All right, take a second and solve for the y component of force 1, and then come back to the video and we will check your answer. Okay, so you should have that force 1 sub y and force 1 are going to be the adjacent and hypotenuse. Adjacent and hypotenuse is the cosine. So you should have cosine of 15 degrees equals force 1 sub y over force 1, which again, remember, force 1 is 750 pounds, so we can just fill in 750 pounds. Okay. Solve for force 1 sub y, we multiply the whole thing times 750, cancels here, and we end up with 750 times the cosine of 15 degrees equals force 1 sub y. Force 1 sub y equals, get out the calculator, we take 750 times the cosine of 15, and we get 724.4 pounds. 724.4. So we get force 1 sub y equals 724.4. Okay? Hopefully that makes sense. You are going to do the exact same thing for force 2 and solve for component forces x and y for force 2. So go ahead and take a second, pause the video here, solve for force 2, and then come back and we'll check your answers here once you've figured it out. All right, so we're back. Here's a free body diagram. Force 2 acting at 25 degrees clockwise from the positive y-axis. Force 2 equals 1,500 pounds. And we have broken out force 2 sub y and force 2 sub x. Okay, so now that we've broken those out, we can solve for the component forces on these. 25 degrees is my angle, force 2 sub x is my opposite, force 2 is my hypotenuse, opposite hypotenuse is my sine. So sine 25 use my son throwing a Captain America shield in, equals force 2 sub x divided by force 2, which we're just going to put in as 1,500 because we know it equals 1,500 pounds. Multiply the whole thing times 1,500, and I'm running off the screen here, and we end up with 1,500 times the sine of 25 equals force 2 sub x. All right, so we grab our calculator and we take 1,500 times sine 25, and we get 633.9 pounds. So force 2 sub x equals 633.9. So we'll record that up here. Force 2 sub x equals 633.9. Okay, now force 2 sub y. Force 2 sub y is our adjacent. Force 2 our hypotenuse. Adjacent hypotenuse is cosine 25 equals force 2 sub y divided by force 2, which we know is 1,500. Multiply the whole thing times 1,500, and we get 1,500 times cosine 25 equals force 2 sub y. Force 2 sub y equals 1,500 times cosine 25 equals 1359.4. Now we move on to step 3. We sum all the forces in the x and all the forces in the y direction. Now, if we look at our y direction, force 1 sub y is going upward. That's a positive force. Force 1 sub x is going to the left. That is a negative force. Force 2 sub y is going upward. That's a positive force. Force 2 sub y or x is going to the right. That is a positive force. So we do have to pay attention to positives and negatives here. So we are going to sum the forces in the x direction. Forces in the x direction are going to equal, we're going to do force 2 sub x because it is going right here, and force 1 sub x is here. Okay, so force 2 sub x is a positive force, so force 2 sub x. Then we are going to subtract force 1 sub x because it is going in a negative direction. Okay. Now all it is simple plug and play. 633.9 minus 194.1, and the resultant force x component equals 439.8. Okay, so we're going to write that up here. We're going to say force x resultant equals 439.8. Okay. We do the exact same thing in the y direction. So take a second, do the y direction, and see what you come up with. All right, so you look at sum of forces in the y direction. Force 1 sub y going vertical, so it's a positive force, plus force 2 sub y going vertical, positive force going up. both forces are going up, so 722.4 plus 1359.4 equals a force Y resultant of 2083.8. So let's just write that over here. Force Y resultant equals 2083.8. And that gives you your two resultant force components, X and Y. Hopefully that all makes sense. Now it's time to move on to step 4, and that is to calculate the resulting force vector from its X and Y component. So we took a look at our X and Y components here. Forces, our force resultant in the X direction is going positive, so it goes out this way, and our force X resultant force we know equals 439.8 pounds. And then we have our force resultant Y, which is a positive force, so it goes upward, and our force resultant sub Y equals 2,083.8 pounds. Right? And that force is going upward. So then we can figure out that our resultant, so our force resultant would be here. And so we would take our force resultant Y component and put over here, transcribe it over here to make our triangle like so. And then, since we know the length of this side, or the magnitude of this side and the magnitude of this side, we can now use Pythagorean theorem to figure out the magnitude of the resultant force, which, remember, a squared plus b squared equals c squared. So a squared plus b squared equals c squared. A being one of these sides, so let's say 439.8 squared plus 2083.8 squared equals c squared. In order to get c, we have to square root the entire thing. So we end up with the square root of 439.8 squared plus 2083.8 squared equals C, or our force resultant. So when we type that into our calculator, we get an answer of the resultant force magnitude equals 2,129.7 pounds. So that is the magnitude of our resultant force. Our resultant force equaling 2,129.7. All right, so the last thing we've got to do is calculate the angle of your resultant force, the angle that it's acting at. We're going to look at theta here, and we're going to look at the opposite side over the adjacent side. So that's going to result in us using the tangent function. Tangent equals the opposite over adjacent. So the tangent of theta equals the resultant force y, right here, divided by the resultant force x, right here. So we plug those two in. Then in order to isolate for theta, we multiply the whole thing by tangent -1, which is the inverse of the tangent. And we get theta equals tangent inverse of 2083.8 divided by 439.8. That gives us a theta of 78.1 degrees. We report this vector, the resultant force, the way we report it is this. All right, the force resultant equals 2,129.7 pounds 78.1 degrees counterclockwise of positive x-axis. You could have very easily calculated this theta over here and done clockwise of the positive y-axis. It would not have mattered. The magnitude would not have changed, and this would not have changed. This is your final answer for all 4 of these problems. That's how it should be reported. If you've got any questions, please get a hold of me on the Remind. Hopefully this made sense and was helpful. Good luck.